Hello, everyone, and welcome back to what is already our closing keynote for the day. Wow, this day went absolutely by in a minute. And as usual, we save the best for last. And we have a new keynote to introduce to you today, George Firican, who is going to talk about the role of metadata in business and AI. George is a passionate advocate for the importance of data and a frequent conference speaker and YouTuber, being ranked among the top 5 global thought leaders and influencers on big data, digital disruption, the top 15 in innovation, and a LinkedIn top voice. His innovative approach to addressing data challenges received international recognition through award winning programs and project implementations in data governance, data quality, business intelligence, and data analytics. He advises organizations on how to treat data as an asset, and he shares his practical takeaways on social media and various industry websites and publications. George has been a data professional for more than 15 years. One of George's passions is to create informative, practical, and engaging educational content to share with individuals around the world. George is the proud founder of LightsOnData.com and its YouTube channel, and he is the co-host of the Lights on Data show. You can see why I'm super excited to introduce George to you today, and I can really not wait to hear and listen to his closing keynote for today. George, it's an absolute pleasure to have you with us today at Big Data Days, and the floor is all yours.
Likewise, thank you so much for the lovely introduction, and thank you again so much for having me. It's my honor and pleasure to be here with you, and thanks everybody for sharing your time with me. While we go over the role of metadata and business in AI, kind of really in everything. Metadata is at the core of everything, in my opinion. So I want to start with a personal story. I don't know if you can detect, but I do have a bit of an accent. That's because I'm originally from Romania, Eastern Europe. And I came to Canada with my parents when I was about 15. My English was good, but not perfect. There were certain intricacies of the English language that I couldn't really understand. I'll give you this one example. I was sitting at my friend's house. We were on the couch in his living room playing a video game. I think it was like Mario Kart or something. It was fun. And all of a sudden, from the garage right next to the living room, there was these really, 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 really loud noises, banging, clashing, clapping. It was so loud that I could really barely hear what was happening on the TV, what was happening with the game. So I was asking Justin, hey, what's going on? And Justin goes, oh, it's just my dad. He's making a racket. And I thought in my head, like, wow, that's so cool. Justin's dad is building rackets, like tennis rackets or badminton rackets. I don't know. Well, that's not what he meant. Making a racket, it's also a synonym or another way of saying making a loud noise, making a bang, making a ruckus. So here's why I'm sharing this story with you, because I feel that we have similar misunderstandings in our current workplace, and not necessarily because some of us are not native speakers of the language that we're working in, but really because of the intricacies and the context of our business. And things like that create problems, right? We have problems when different units are referring to the same term, like customer, but really meaning different things. When a report or a data pool is being created by 3 different people, you can get 3 different answers for the same request. We have problems when we're feeding our AI all these misunderstandings, right? We have problems when our stakeholders are losing confidence in data, or even worse, making decisions based on incorrect information because of a lack of a common understanding. We have problems because people spend hours kind of chasing information that they cannot find, or when they do find it, they find it in multiple areas and it's conflicting. And again, these problems can get compounded with AI. So there are problems, but I do think that all problems are opportunities in disguise. So today we're going to see how metadata and the tools that house it, such as the Business Glossary, the Data Dictionary, Data Catalog, Machine Learning Metadata Store, are creating some of these opportunities. So to do that, let's talk about the sandwich. Yes, you heard me right. The sandwich, you can have it for breakfast, lunch, and dinner, and it can be delicious. I think we all know what a sandwich is, right? I think we can all identify a sandwich when we see one. I'll give you these 3 options. Feel free to put in the comments which one of these would you say is not a sandwich? The hot dog, grilled cheese sandwich. I mean, that must be a sandwich because it has sandwich in the name, unless I'm trying to trick you. Or the burrito. Well, I'll come back to this slide at the end of the presentation. I'll tell you what I think, and I'll give you some interesting fun facts as well. But yeah, feel free to let me know in the comments. And what do you think AI's identification of a sandwich would be? So a few years ago, FoodVisor raised about $4.5 million for its AI-driven app that kind of really helps companies track what you eat. And it's doing a pretty good job still. The idea is you're taking a photograph of your food and it gives you all the calories and components of whatever it's being able to identify on the food. And it's pretty good. But it's all about the context, because if you're using the app to photograph a chihuahua, you might think it's a muffin. If you're putting a parrot, you might think it's like guacamole. A labradoodle might think it's fried chicken. So again, it's all about the context. And it's because of the metadata that's been trained on with, it's thinking that whatever you're feeding it has something to do with food. So here's why I'm bringing this up as an example. Let's say that you have a project that involves data on sandwiches, and you're either a data professional, a business professional, or even from the point of view of an AI algorithm. And maybe your company wants to start selling a new sandwich on the market and wants to see if it should. Or you want to develop a new marketing campaign that targets sandwich foodies. Or again, you are an AI algorithm. So let's think of it from that perspective. And you're trying to predict what sandwiches will sell most. There's a few questions that come up because of that. I don't know if you've heard of Ryanair. Ryanair is this low-cost airline that's operating in Europe mainly. And what really a few Ryanair passengers realize as they bite into their sandwiches is that the trolleys rolling down the aisle are really serving more than snacks. Those trolleys really are a vital source of information about what's being requested, what's being sold, which is fed into this machine learning tool, which internally they've nicknamed it the Panini Predictor. And this Panini Predictor is basically helping the airline forecast precisely what type of sandwiches to put on which plane. But why? Why would they need something like this? Well, because it's a bit more challenging to kind of calculate how many people will opt for, let's say a ham and cheese panini for, any given flight that they operate. And that's because the company has more than 500 aircrafts, runs about 2,900 flights a day. And one single plane can traverse multiple routes across multiple countries. Of course, each plane has limited space, about 5 trolleys worth. And it can only be stocked once every 24 hours. So it's very important for them to be able to predict based on the locations that they're flying to and from, and the type of maybe people, gender, age that they would have, to try and predict what type of food they should pack, right? Because it's they have like 3 things that they want to make sure it's happening. They want to make sure that the customer is satisfied. They want to make sure they're not creating waste and losing revenue. And of course, they want to make sure they're really optimizing those sales. So they're selling as much as they can. They're going to empty those trolleys by the end of the 24 hours, right? So still, the question is, what data do you include in a project, even like that? You have all these different data sets. Do you include data on paninis? Sure. For Ryanair, absolutely. But what about hot dogs, burritos, any other types of sandwiches? Do you include it? Well, it kind of depends on your company's definition of what a sandwich is. And that's where I want to start. This is a definition from the United States Department of Agriculture, which says a sandwich is a meat or poultry filling between 2 slices of bread, a bun, or a biscuit, which means technically that the grilled cheese sandwich is not a sandwich according to the USDA. And that's because the USDA only covers the labeling of meat, poultry, and egg products, while the Food Drug Administration kind of handles everything else. So if you worked for the USDA and you included data for your project on grilled cheese sandwiches, you would actually end up with invalid results. It would not, it would really skew the results of the project if you worked for that organization. So, again, we all come with these assumptions based on our life and work experience, and we bring those assumptions into the workplace without always validating them. Maybe we're less likely to make wrong assumptions on what a sandwich is, but there are plenty of business terms out there that kind of seem maybe obvious what their meaning is, only to find out that's not the case. So for example, customer, I think it's a great example. You're asking two different people in your company how they define what a customer is, and you probably get like 3 different answers, if not more. These examples are from a session I've done a few years ago with a client, and these were the 3 definitions that they came up with to actually determine what that official definition was. Took a few weeks. It wasn't easy. But again, making assumptions on meanings of business terms such as customer, cell conversion rate, credit, GPA, you name it, is really what creates certain challenges in the workplace. And of course, it creates even more challenges for AI. Right? So we do need to have a way to avoid these challenges. So we need to have this trusted place where business metadata is being recorded in our organization that we can refer to, because we know it's information that's been approved, it's information that's been curated, maintained, so we can see, what terms such as sandwiches. So we find something like that, the definition, but also a bunch of other attributes that you can see here. Anywhere from the data steward, that we can go ahead and ask more questions related to the data, to that sandwich in this case. Owner, source, classification, any related policies. I mean, there's a lot of different attributes that you can have. I've worked with companies that they've had anywhere between 20 to 50 to 100 attributes being recorded for a single term. So yeah, 100, maybe it's a bit on overkill, but there's definitely a lot more information that you can record there. So all of this information we would find in a business glossary, which is this collection of business terms with their unique definitions and other useful related information. Yes. So that's the business metadata. That's where we record it. What about the other side? What about the technical metadata? So let's say that we now know what a sandwich is, and because of that, what data sets we should include in our project. So let's say that we're looking at a data set similar to this, and this is actually a sample from a data set collected from a quick serve sandwich chain. But we should understand what we're looking at here. What do all these columns mean? What are the type of data that they contain? What are some of the specifications, the default values, the type of keys, and so on? All this information, by the way, it's also very useful if you need to do any ETLs, ELTs, reverse ETLs. And not only, it's also good for you to gauge if the way the data were recorded fits the requirements of your project or not. So it's a good way to understand if you need to do any data wrangling, any data munging before that data is available for your AI project. So all of this technical metadata we can find in a data dictionary. So this data dictionary kind of gives you the specifications about really a field in a database. So let's do a really quick recap. We have the business metadata, we have the technical metadata. The business metadata is recorded in the business glossary. And we then find the technical metadata in a data dictionary, which again gives you the specifications about the fields in a database. The business glossary is business owned because it holds our business verbiage. It's this curated place where we can find definitions such as what a sandwich is, at least from your organization's point of view. And we usually have one business glossary for the entire organization. Now, the data dictionary provides a very application or technology-centric view of the data. It provides the description of a data element and its metadata. You can have many data dictionaries, usually one for each application or database. That being said, the Business Glossary and the Data Dictionary, they can be connected, they can reference each other. Now, for the data catalog, I think the best way to understand it is to take a look at Amazon. Why is that? Well, we know that Amazon carries millions of different products, and yet, as consumers, we can find almost anything fairly quickly. At least that's my experience. In this case, I was looking for grilled cheese sandwich cookbooks, typed that in. I found a few options, clicked on one. Yeah, it's pretty good. Pretty good. And, beyond Amazon's advanced search capabilities, they also give detailed information on each product, right? Obviously, we have the description, and we have all these other metadata. In this instance, because it's a book, we have metadata related to the fact that it's a book. So, things like if it's hardcover or softcover, how many pages it has, how much it's weighing, its dimensions. Of course, we also have customer reviews, which I think we all value, and we kind of based our purchasing patterns due to it at times. We have that, related products and photographs and other things. So the data catalog works in the same way for your databases, for really any data store, really. And the purpose of the data catalog is to organize the thousands or the millions of an organization's data sets to help users search for and find specific data and understand its metadata, and then download it or request access to it, kind of depending on that implementation that you have in the organization. So let's look at an example. And because I'm trying to be very agnostic with the products here, I was looking at data.gov, which is this data catalog for open data from the US government. And this is a data set on dietary intakes from a national survey. And I chose it because it contains data on sandwich consumption as well. So similar to Amazon, we have the description that we see here, a big block there. We also have, privacy policy. And of course, we can download the data set. But also we have a bunch of other metadata, such as, who's the owner, who's the data steward. It also has a link to the data dictionary. And some actually even have reviews from other people that have used this data set. So this single point directory kind of offers the user the ability to locate information and further provides the mapping between the Business Glossary and the data dictionary. And by the way, the reviews there, I think that's so key. And I've seen that in a lot of data catalog implementations. And it's so key because now you're kind of, again, crowdsourcing that information, and you're relying on other users' experience with that data set. And it can tell you things about the, how they found the data quality level, maybe even put in their own definitions or notes saying, hey, kind of watch out for this one. Or it's actually a bad review because I feel that the description or even the title of that data set doesn't quite match my expectations. So, watch out for that one. All in all, I think it's such a great feature to have. And again, as I mentioned, all of this, once you do have it, you can download it or you can request access to download it. And most organizations, I think they kind of have that layer of protection, let's say, that you basically put in a request, you put in your project's information and the reason why you want to have access to this data set. And then the data governance team usually are the ones that are kind of curating all of that access, and they're providing access to you. All right. And happy to answer more questions about that in afterwards too. So the Machine Learning Metadata Store. Let's start with like a really quick high-level overview recap, I guess, of machine learning. So really the process of building machine learning models is kind of vaguely similar to conducting a science experiment from theory. You start with a hypothesis, you design a model to test your hypothesis, and then you kind of test and improve your design to suit your hypothesis. And then, you pick the best method according to your data. So with machine learning, again, you start with a hypothesis about which input data might produce desired results. You train the models, you tune in those hyperparameters until you build a model which produces the results that you need, that you're looking for. As shown in this diagram on the left there, courtesy of Jeremy Jordan. And of course, storing this experimental data really helps with comparability, reproducibility. So I want to talk about the 6 main metadata types that we need to track in this metadata store in order to make sure that we're comparable and reproducible. The first one, it's the model itself, because until the end of the experiment, let's say, it's kind of hard to put a pin on which model to proceed with. So it's useful and definitely saves a lot of time if all those experimental models are reproducible. So you want to store that information about it. Then we have those feature pre-processing steps. And here's why. So we have this raw data that has already been accounted for and saved to be retrieved, but this raw data is not always fed to the model for training. In most cases, the crucial information which the model needs, i.e. the features, are picked from the raw data and they become the model's input. And at times we need to have these pre-processing steps that we need to take. As examples, feature augmentation, dealing with missing values, transforming into different format that maybe the model requires, and so on. So all those pre-processing steps we can save in this metadata store. So then we know the steps that we need to do to reproduce it, or even apply it to the next model too. It saves us time for sure. The hyperparameters. Now, the machine learning model usually has this loss function or cost function. And to create a robust and efficient model, we aim to minimize the loss function. And the weights and biases of the model where the loss function is minimized are the hyperparameters that need to be stored to reproduce the efficient model created earlier. So we definitely want to store that. The data, of course, data used for the model training and the evaluation. Here we can actually bring in things from the data dictionary or even the data catalog, things like column names, the types of data. But then we might also have stats of the data set, even maybe the pointer to the data set's location. We also have the metrics, second to last. So these are the results from the model evaluation. And of course, those are important in understanding how well you have built the model. So then you can compare it to the next iteration and see which one fares better. Are you going into the right direction or are you not? And then we have the technical context, right? For the technical context, the model context is information about the environment of a machine learning experiment that may or may not affect the experiment's output, but could be a factor of change in it. So for example, things like the source code, any packages and their versions, programming language and their versions, maybe even like the host information. There's plenty of examples, I think, all these environmental variables, system packages, etc. Again, things that normally would not affect the output, but it could be a factor of a change in it. So I think that we can see that when we're working with data in whatever capacity, we can really benefit from these 4 tools: the Business Glossary, the data dictionary, data catalog, and the machine learning metadata store. So the Business Glossary, again, is for your business verbiage. The data dictionary really describes your data elements. The data catalog is helping you find the data that you need and maybe even gauge its usefulness and request the right to use it. And the machine learning metadata store it really ensures that rapid model optimization, that transparency, that reproducibility by having all that information about your model in there, about your machine learning. As I mentioned, a business glossary and the data dictionary, they reference each other. And we can often find all this information put into the data catalog. Right. Now, I mentioned in the beginning those three, the hot dog, right? The grilled cheese sandwich, the burrito, and I was asking which one of those is not a sandwich. I wanna see if anybody put in any comments in here. I believe they all are because they have bread with something in the middle. That makes sense. Yeah, Ryan. I think you're kind of right on that one because in the end it kind of all depends on the definition, right? Burrito, there is no bread. Tortilla can be considered flatbread. I love all those comments there that you're all having there. Yes, company needs to document data, and leaders should start thinking from data-driven perspectives. I completely agree. But let me just wrap up the what I mentioned about those three options. Again, I think you'll understood what I was trying to say there. That it does depend what your definition is. And here's a really maybe real example that I've noticed in the state of New York. So in the state of New York, they have different types of taxes, as you would in, I guess, in different parts of the world, but they actually have a specific tax for sandwiches. And they are taxing the burrito in the same way that they are taxing a sandwich. So from a tax perspective, the burrito is categorized, classified as a sandwich. So again, it goes to show you, maybe if you are in New York, if you go to New York and you order a sandwich and you get a burrito, now you know why. It's all about the definition. It's all about all these different assumptions that if they're left unchecked, then we can get into problems, right? Imagine working for, let's say, one of these organizations, and you would never thought that the burrito would ever be considered a sandwich, but from a tax perspective, it is. You're not including it in your analysis, but you might be seeing in some of your reports. It's really skiing up your data, your results, and of course, any decisions that you make on it. So it's challenging if you don't have this trusted place, this trusted source of information where you can go and validate your assumptions. And for that thing alone, I think a business glossary, for example, to start there, it's something that we all need to have as part of our onboarding, as a source that we know we can go to and validate. And then, of course, for the technical pieces, anywhere from the data catalog, the data dictionary, and specifically for the data analytics, data science teams, to have the machine learning metadata store to make sure everything else goes well. So I want to take any questions that anybody has, and feel free to fire away. One thing that I do want to note is.
Oh, sorry. Thank you so much, George, for a wonderful presentation. I think you covered the sandwich analogy quite good, and it's also, I think I always like visualizations in the presentation because it immediately put things into perspective. So thanks so much for sharing your insights. We have quite a lot of questions that came in during your presentation. You can see them in the question box, but I will moderate them and we will go one by one.
Yeah.
The first question that I have, and this one received the most upvotes, so I think that this is the question I'd like to start with, is a question from Ryan. And Ryan is asking, the session uses the sandwich recipe analogy for data and metadata. If data is the recipe and metadata clarifies the ingredients and steps, can poorly defined or inaccurate metadata lead to garbage in, garbage out situations in AI systems, even with high quality data? What's your thoughts on that?
Yeah, no, absolutely. And especially with that machine learning metadata store, if that metadata that you're recording on how that model should be constructed and utilized, even if it does rely on great metadata, but you're kind of messing up on how you're recording that metadata about it. Sorry, even if it relies on proper data, if the metadata within the machine learning data store is improperly being recorded, then of course you're not going to end up with the proper results. You can even introduce a lot of bias to it as well, your own bias that can go into those into the metadata. And it's a slippery slope too. And it's, I've actually seen it a few times where that machine learning algorithm is not being able to be reproduced because of that poor metadata that's being recorded as a result. And the other one, for kind of anything else, let's say that metadata is good. Let's say that we have a column on age, but instead we're recording it that, oh no, that column doesn't represent age. It represents the last 2 digits of the year of birth for somebody. Well, then you would infer what the age would be completely different based on it. And there's so many, I think, other different examples. So absolutely, data, metadata, they come together, and they both need to be taken care of. That recipe needs to be properly created and maintained as well. So the recipe can change too.
Yeah, absolutely. Good. Let me then move to the next question, which is from Katina. Let me project the question on the screen. And the question is, how do open source machine learning metadata stores compare to proprietary solutions in terms of functionality, scalability, etc.?
And that kind of goes with any open store, but what you need to be careful of is what type of calls it makes outside of the organization that you need to, I would always recommend to do some sort of a privacy impact assessment to understand what data it's able to shoot back. Sometimes with open source ones, you are also like giving away something. One of the good things about open source is that it can be more, let's say, customizable, easier at times, because you have access to everything. So if you have skilled people on your teams, they'll probably be able to customize it in any way that you want. Whereas with proprietary solutions, you have less options there. You need to go through the provider, but at the same time, it can be unmanageable at times. Starting from the open source solution, it becomes in a way your own proprietary solution as it's modified long enough that it doesn't resemble. Yes, it's using the common packages and everything, but it's nowhere in the same shape or form as you've originally implemented it, and then that can become a challenge to manage it. But in terms of some of the functionalities, I think they can be on par for a lot of them. But again, the scalability is something that you need to be mindful of, because now you're taking over that ownership. With any update from the open source, you need to take care of it yourself, and especially if you've done any customizations, you need to manage the impact on those customizations. So I think you do need a team to be able to take that on as a full time. So you need at least 1 to 2 people, if not more, depending on the complexity of whatever you've implemented.
Yeah. So yeah, the knowledge aspect, I think, remains a critical part there, right?
Yeah, absolutely. Yeah, we need like another metadata store for that. Yeah,
that's a very good idea. Good. I think we still have time for some more questions. I'm just going to keep going through the upvote. So in case you would like to see questions answered, please use the upvote functionality in the Q&A box. Next question, and then I'm going to project, is, are there any specific recommendations for organizations to mitigate risk associated with the use of metadata in AI projects?
Yeah, so the machine learning metadata store is really good for that, but as well as the data catalog. The idea is for these tools to be accessible to the business end as well, for them to be able to get an insight. We don't want the machine learning, the AI project to be this black box that it's most of the time it is, at least on the business end. So when they're making decisions and that decision is wrong, they want to know, why was I informed that that's how I should act, and I did, and I listened to you. What's happening in this AI algorithm that's providing me with that. So you want to be able to provide them with tools and ways for them to either ask the questions or look into them themselves. So having it open to the business, make it transparable, also increases the trust a lot. And I think it also reduces the risks, as now you can have more eyes on it. You also want to instill a culture of common responsibility. It's not just a data team, just the data science teams or IT that is responsible for these things. Really, it's everybody, right? Same with data quality and data governance. In a way, it's everybody's responsibility, even though you do have dedicated people to kind of take care of it. But the idea is that if somebody sees something wrong, they have a feedback loop that they're able to provide that information back. So yeah, that's one way for these risks to be mitigated.
Great, thanks so much for sharing that. I'm going to move to a final question, and the final question that we're going to be looking at is a little bit more industry specific. Final question is coming from Shamunga Sundran Asami. What's your thoughts on seeking metadata from health sector? Are the healthcare institutions open to document metadata towards precision medicine? Please share if any case studies on reinforcement learning in healthcare industry.
I don't off the top of my head, at least I don't know of any case studies on reinforced learning in the healthcare industry, but there are actually quite a few nonprofits in the healthcare, especially like in Europe and I know Canada as well. But they do have some open data sources that you are able to refer to. They even have sort of like data dictionaries and business glossaries per se, where they offer all these different metadata around common terms and things like that that can really provide a good starting point if you ever want to build your own, or you need to rely on something that's sort of like industry vetted and approved. Sorry, let me just read this. Are the healthcare institutions open to document metadata towards precision medicine? Yes and no. And of course, for the for-profit ones, and when it comes to creation of drugs and things like that, there's a lot of proprietary information. But then, as we know, as the patents kind of expire and we have the generic ones, that information is available out there. Now, some of it you can purchase, or some you can just access, but it is available. Though, as I mentioned a lot, in especially the drug making industry, if it's something that's under development or under a patent, it's something that you would not be able to use that information. I mean, with a patent, you're able to see the information related to the patent, but you would not be able to use that information to build anything on it, unless there's probably some sort of a contract that you pay them, and there's all these models. But take a look there. I know within Canada there are a number of healthcare institutions and hospitals. They're using readily available data that they're sharing from one another, and publicly available data as well when it comes to the healthcare sector. So they're using that information to better their patient outcomes, even monitor things like flu trends and outcomes, and there's a bunch of stuff. Even during COVID, I mean, they were releasing a lot of that information so that even the public would be able to take that on and see, can they help with anything? Can they kind of run their own studies, or build their own apps, or do anything with it?
Very, very interesting. Thanks so much for that. George, it's been wonderful listening to you. Before we say goodbye, there's still one key point in terms of the logistics that I need to do. And that is throughout all the keynotes and the breakout sessions, there is a quick poll for people to win access to books and e-learning courses, etc. So if you don't mind, I'm going to quickly run that right now, because the final question for today's quiz, which is question 3 out of 5, is which AI program was the first to defeat a world chess champion in a match? So first, George, I'm gonna, before saying the answer, would you know the answer to this question?
Deep Blue.
Oh, well, I'm going to ask everyone to vote now, so we're kind of giving it away. Don't worry too much about it.
But don't take my word on it.
Good. So this is indeed a specific machine that was specifically generated for that purpose. I see that, unsurprisingly, a lot of the people will indeed vote according to the expert. So we'll keep the poll open, and this is kind of a giveaway question from our side. A few more seconds, and there we go. And indeed, not surprisingly, everyone has indeed voted for Deep Blue, which is the machine that was developed by IBM at that date. So to close the session, because George, you're actually the last one for our day number 1. But the good news is that we have a full day again tomorrow, in which we have another 18 presenters, 2 keynotes, and a breakout session again. So by all means, I would like to invite everyone to join us again during Big Data Days 2024 for the second day of the program. With that, George, I would like to thank you so much for being part of Big Data Days 2024. I hope you enjoyed the presentation and the format. I see almost hundreds of clapping hands going up in my screen, so I'm quite sure that the audience liked it as well. It's been absolutely wonderful having you with us today, and thanks for sharing your experience and expertise, and I'm definitely going to memorize that sandwich analogy for a very, very long time.
Thank you as well.
Good. That concludes our program for day number 1. I wish everyone who's joining from everywhere in the world a good rest and get some good sleep, and we'll see each other again tomorrow during the second day of the program. Thanks, everyone.